Okay, so this is example 16.4. It says determine whether or not this is a redox reaction. If it is a redox reaction, identify which atoms are oxidized, which ones have changed, and tell whether they were oxidized or reduced. So a redox reaction, if you see one thing that changes from a positive to a negative, or it gets oxidized or reduced, something else has to gain those electrons. So if something's losing electrons, something else has to gain electrons. That's what makes a redox reaction. Redox means something's reduced, something's oxidized. So here we have Ca plus Cl2 turns into calcium chloride. Okay, so rules say if there's no overall charge and it's one thing, my oxidation number is 0. Here I have one thing, it has no overall charge, so my redox number is, oxidation number on chlorine is 0. So here it's 0 and 0. But here I have calcium, which from my rules is +2. And here from my rules, chlorine is -1, and there's 2 of them. That gives me an overall 0 charge because -2 and +2 gives me 0. So calcium went from 0 to +2. Is that oxidized or reduced? Remember, Leo says GER. So if something is losing electrons, it's being oxidized. So from going from 0 to +2 means I lost 2 electrons. So this one is oxidized. And chlorine went from 0 to -1. So when you get more negative, you are gaining electrons. And so that is reduced. Reduced. I think I spelled that right. So this is a redox reaction. This is oxidized, this is reduced. Okay, and you can tell because their oxidation numbers changed. So now we have silver, and again, this has an overall charge of +1, so there's only one thing there, and so it's got to be +1. Here we have oxygen and hydrogen. This is going to be -2, this is going to be +1, and there's an overall charge of -1. So let's look over here. Now we have Ag is still +1, O is still -2, hydrogen is still +1. So that is the same number, same number, same number. So all I would say is this is not a redox reaction. Done. Okay, so there are going to be some that are not redox reactions. If you see the first thing doesn't change, probably it's not a redox reaction. So now we have this reaction. On this side, F is -1, and there's 5 of them, which means that this has got to be +5 iodine. I didn't really have a rule for that, but I can figure it out because F is always -1. Okay? And iron is all by itself, and there's no charge on it, so it's got to be 0. So if I see anything change over here, it's a redox reaction. So let's look. F over here is going to be, here we have, did I write this right? Yes. Okay. Then, because Fe went from 0 to, this is going to be a -3 because there's 3 of them, and F is always -1. And so this has got to be +3. And here, F is -1, and there's 3 of them, so that's -3. So iodine has got to be +3. So here, iodine went from +5 to +3. So +5 to +3 means I would have +5 to +3. From +5 to +5, from +5 to +3 means I would have lost 2 I would have gained 2 electrons. 2 electrons negative gained. And here I have iron that's going from 0 to +3. So he would have lost electrons. So the iodine here would have gained electrons, that's reduced. And iron here lost electrons, so that's loss of electrons is oxidized. Oxidized. So you'd say yes, this is a redox reaction, and iron was oxidized and iodine is reduced. Okay.